Hi, my name is Sebastian Matteau, and today I want to show you how you can work with objects and attributes in Python. Now, what do I mean by object attributes? I simply mean that you can have an object such as a kitten. So I will use the example of a kitten in this screencast. And our kitten has two properties or two attributes, namely it has a name and it has an age. So that's all that I mean. Simply an object, a kitten with some attributes such as a name and an age. Now, you can represent a kitten with a name and an age in a few different ways in Python. And the goal of this screencast is simply to show you these different ways, these different approaches, and to kind of discuss the pros and the cons of each approach so that you can decide for yourself which approach is best in your particular situation. So now I'll start with some very simple approaches and then go towards more complicated approaches. Let's start with the simplest possible way to represent a kitten with a name and an age, simply using a list. So here you see that we've created a list, K, and the first item in the list at position 0 is the name, Minu, and the second item in the list at position 1 is the age of Minu 2, right? So, and then we can run this. You see it comes, if we execute it in the debug window, you see it prints out Minu is 2 years old. Right? So a list is a fine way to represent a kitten with a name and an age. The main advantage of using a list is that it's really simple. The main disadvantage of using a list is that you need to remember by heart, essentially, the position of each of the attributes in the list, right? So we need to, in order for this to be correct, we need to remember that at position 0 we have the name and at position 1 we have the age. Now, because we only have 2 attributes, that's not such a big problem. But if we have, say, 20 attributes, that becomes very difficult to remember, right? And then if we make a simple mistake, we say, for example, we flip this around because we forgot the order in which the attributes are in the list, and I run it, it suddenly crashes, right? Because we mixed up the name and the age, and our code crashes. So that is a very big downside. It's not in most cases, well, it's not a very good way to represent a kitten with a name and an age, but it's possible. A slightly more complicated way is to use a dictionary instead of a list, or a dict. Now, a dict is kind of like a list in Python. The main difference is that a dict doesn't have a particular order, so the elements in a dictionary don't have a particular order, but they have a name. So our attribute Minu has the name, which is nice because Minu is a name. And our attribute 2 has the name age, which is nice because 2 is the age of Minu. Right? And then if we run this, you will see, I select it, I run it, it again prints out Minu is 2 years old. So it's a good way to represent the fact that we have a kitten named Minu of 2 years old. Now, the main advantage of using a dict over a list, as I already said, is that now we don't need to remember that that the name comes first and the age comes second. We only need to remember that the name has the name and the age has the name age, which is kind of natural, right? It kind of fits our very verbal way of thinking better than remembering the positions of attributes in a list. And also you can access say that we want to access only the name of Minu, we say K, and then we, between square brackets, we put the name, and then that works. So I run it, prints out only Minu. Right, so it's a pretty clean way to access the attributes of our kitten. So what is the main advantage? Again, it's quite simple, right? Doesn't require a lot of complicated code. It has the advantage that now our attributes are named, right? So we don't have to use orders anymore. So that's pretty okay, right? So dictionaries are an okay way to represent objects with attributes as long as the situation is quite simple. Now let's move on to a slightly more complicated approach using a so-called named tuple. Now, a named tuple is kind of like a list and a dict, but it's part of the Python standard library in the sense that you don't need to install it separately, but you do need to import the named tuple. So you say from collections import named tuple. Then how it works is as follows. It's kind of complicated, so it takes a little bit of there's a little extra layer of abstraction, but just follow me. So what we do is we're going to define a new named tuple. This named tuple has a type name, kitten. So basically it means that the description of what we're going to create is a kitten. It's a kitten that we're going to make. And our kitten has two fields named name and age. And that's what we do here. This doesn't automatically generate a kitten. What it does is it generates a new class, which we saved as namedtuple kitten. And with this new class, we can create an actual specific kitten. Right? So here we kind of define the abstract concept of a kitten with a name and an age. And here we create an actual kitten with the name Minou and the age 2. Right? And we save that as K. Now if I select this, execute it, you see that it works. It prints out Minou is 2 years old. Now this is pretty fine. Right? It looks nice, and I particularly like the fact that now you can access the name simply by saying k.name and the age by simply saying k.age. So that's kind of clean, right? It's a clean syntax. I think the main disadvantage of using a named tuple is that it's kind of complex. I think it is a bit, right? This is a bit confusing what's going on here. It requires sort of an abstract layer of thought. And a very big disadvantage is that named tuples are immutable. So if I say k.age is, for example, 3, I will select it and I run it, it will crash. It says attribute error cannot set attribute. That is because named tuples, once you've created a named tuple, you cannot change it anymore. So we cannot rename our kitten, and we cannot give our kitten a different age. We can create a new kitten, but we cannot change our existing kitten, right? And that's a bit inconvenient in many cases. So that's a disadvantage. I don't personally use named tuples all that often, but there are people who like them very much. But it's in any case, it's a strategy to be aware of. Now, let's move on to another way of representing our kitten with a name and an age, namely using a class. And that's what's going on here. So what we do, if you're familiar with object-oriented programming, you will see right away what's going on here. We define a class, which we've called class kitten. And the class kitten only has a constructor function, an init function, which takes a name and an age, and it has already default values. So by default, kittens are called Minou and they have an age of 2. And the only thing that the init function does is it says self.name is name and self.age is age. In other words, it remembers the name and the age as properties of the object. Now, when we then create, so this, just like before, here we define sort of the abstract idea of a kitten with a name and an age. And then here we create an actual kitten with the name Minou and the age 2. And we save that as the object K. If I select all of this and I run it, you will see that it works. It prints out Minou is 2 years old. So it's kind of similar in many ways to creating a named tuple, right? It has also, you can also access the attributes of the kitten by saying k.name and k.age, which is pretty nice. The main advantage over defining a class in this way instead of a named tuple is that now we can say k.name is Chatnoir, for example. And if I select that and I run it, you see that it works. It doesn't crash. Whereas if this had been a named tuple, this wouldn't have been allowed, right? Because named tuples cannot be modified. They're immutable. And classes, in the way that we've defined them now, they can be modified. They are mutable. So this is that's a big advantage of using classes. And actually, this example that I give you here, it's pretty simple, but it's a pretty common and a pretty good way to define objects with attributes in Python, I think. Now, let's move on to a slightly different way of representing our kitten. And it's actually not even that different. It is more an extension of this approach using class. Namely, using properties. So, here I've defined another class, property kitten. The beginning is quite similar. It has as our previous class, right? So it has an init function, a constructor, which takes a name Minou by default and an age 2 by default, and it saves these as properties of itself. But you will see that it actually says self._name is name and self._age is age. Now, what does this underscore mean? Well, this underscore indicates that you're not supposed to access these properties directly, right? You're not supposed to access _name directly as a user. You can. There's nothing in Python that prevents you from accessing it directly, but you're not supposed to. It's kind of the consensus. Instead, what you're supposed to do is use this property function. So here we've created a function that's called def_name, and it returns self._name, right? So the only thing that it does is return the name. and then it is decorated using this so-called property decorator. And decorate simply means, it's a technique, a Python technique, and it means that you have, well, I won't go into the details, but if you see an at before, and then some, like for example property before a function name or before a class name, that is called a decorator. It's a particular technique. Now, what this particular decorator does, the property decorator, is it allows you to access the name function as though it is an attribute. In other words, say that we have defined a kitten, we can say k.name up, and this will automatically execute this function. So if it hadn't been a property, we would have had to do this, right? We would have had to put these parentheses after name to make sure that it executes this function. But this property decorator makes the execution implicit, you could say, and now we can simply say k.name, and this function will be executed automatically, and the value will be returned. So that's pretty sweet. It's a bit abstract, right? But it's not that complicated. It's not that difficult. Then we have another decorator, name.setter, and this means simply it is this. Wait, one step back. This could be called a getter, right? It gets the name. It's a function that gets the name. And then this would be the setter. It's a function that sets a new name. It changes the name. So this name referring to this function dot setter. And that's a decorator. That's how you indicate that in Python. If you want to know more about properties and setters, you can always find it online. It's kind of, but because it's a bit technical, you can just accept it as kind of a black box magic for now. Basically, how this works is we define another function, and it takes another name. It takes a name as an argument, and it assigns this name that is passed to it to self._name. Right? So it changes the name attribute. Now, normally we would have to do something like this, right? k.name, and then our new name, Chatma, for example, but because we've use this setter attribute, what we can do is actually use the cleaner notation, simply say this. And writing this, k.name is Chatma, would make Chatma be passed as the name and change the name of our kitten. Right? So again, it takes a little bit of abstract thought, but it's not really that complicated. Now, what this function does, in addition to changing the name, is checking whether the name is actually valid. And that's the nice thing of using a setter function. So it checks, basically what it does, it checks whether the new name is actually a string, right, and not, for example, a number, and whether it's not an empty string, because empty names are not nice, right? Your kitten should not have an empty name. And if it is an empty name, or if it's not a string, it will raise an exception and it will crash, right? So it's a validation procedure to make sure that we have a valid name. And for the age, we do the same thing, right? So we first define a function that gets the age. We define a getter function that returns _age, and we make it a property so that we can refer to it as k.age without needing to put parentheses after the age. And then we define a setter function which takes an age and which allows us to do something like this. k.age is 10, for example. It would call this function and 10 would be passed as the new age. Now, what the setter function does is first it checks whether the age is actually a number, either an int or a float, and whether it is not negative, because negative ages don't make any sense. Right? And if there's something wrong with the age, if it's not a valid age, an exception is raised to crash the program. And if everything is fine, the age self._age is simply set to the new age. So again, this is a setter function that validates whether the new age that's being set is actually valid. Okay, so if I select all of this and I run it, it will print out Minu is 2 years old. Now let's say if you want to see the setter in action, let's say for example k.age is -2, right? And -2 is not a sensible age, right? And it should trigger our setter function. And if I execute it, you see that it does, right? It says kitten age should be positive numerical value. Where does this come from, this error message? Well, it comes from our setter function. It comes from this part, raise exception, kitten age should be a positive numerical value. So that's the advantage of using these properties and these setter functions. They give you more control. They allow you to specify what valid attributes are, etc., and how they should be retrieved, etc. So that's a pretty sweet way to represent objects with attributes. Now, the main disadvantage of using this approach is, of course, as you can see just by this piece of code, is that it is relatively complicated. Right? It's slightly more complicated, and it requires a certain familiarity with decorators and also with object-oriented programming. But it's not too complicated, so you will see this quite often. Now let's move on to the final way to represent our kitten using the attr package. So here I say import attr. Now what is attr? I don't actually know how you're supposed to pronounce that. I will just say attr. It is a package that is specifically designed to represent objects with attributes. So it does exactly what we want in this tutorial. It is unfortunately not part of the Python standard library, which means that you need to install it separately. So you can, for example, use pip install attr to install this package. So that's kind of a disadvantage. Now, it is a little bit complicated, so bear with me. Right? Especially the syntax is a little bit odd, I think. So how does it work? Well, we define our class. So again, we have a class. The basis is a class, and we've called it attr kitten. And then to sort of make sure that we're going to use the attr package, we decorate it with attr.s. Now, just take this notation as black magic, right? This allows us to turn our class into kind of a magical class that has sweet attributes. And then in our class we're going to define our attributes in the following way. We say name, so our first attribute is name, and then we say attr.ib. Again, a bit odd, this notation and this name, but that's the way it works. So it simply means we're going to create a new attribute. It has a default value minu, and it has and this is important, it has a validator. And the validator is validate name. Now what is validate name? It is simply this function right here. And that function checks whether if we're going to change a name, whether this, okay, let's track back. What does this function accept? First, k, the object that needs to be validated. Then the name of the attribute that needs to be validated. And then the value, which I've called here name. In other words, if we're going to validate the name, then k would be the kitten object, attr would be name, the string name, and name would be the actual name, for example, Minou or Chat Noir or whatever your kitten is called. And the only thing that this function does is check whether the new name is actually a string, so it has to be an actual string, and it should not be empty. And if it is not a string, or if it's empty, an error message is raised. So it validates the new name. And for the age, the principle is the same. So we create a new property age with this weird attr.ib, has a default value 2, and it also has a validator function, validate age. And validate age is this function, which as a first property takes our kitten object, then the attribute that needs to be checked, which is age, in this case, string age, and then the actual age that needs to be checked. And what it does is it checks whether the age is actually a numeric, an int or a float, and whether it's actually not negative, because we don't like negative ages. So, and if there's anything wrong with the age, an exception is raised. Okay? Now, once we've defined our attr kitten in this kind of ugly way, we can create an actual kitten, right? So again, here we kind of define the abstract concept of a kitten with a name and an age. And then here we define our actual kitten with a name Minou and an age 2. And then if I select all of this, I run it, you will see that it works. It prints out Minou is 2 years old, right? So that it comes from here. Some people really like the attr package. I guess there's something to be said for it. I personally think that the syntax is quite ugly. So that's definitely a downside. And another downside is that it requires you to install a package that is not part of the Python standard library. But it has a few nice tricks up its sleeve, so it's definitely something to be aware of. So after having looked at all these approaches, using a linked list to represent a kitten, a dictionary, a namedtuple, a class, a more advanced class using setters and getters, and finally the attr package. So what would be my recommendation? Well, I think in general, in most cases, you will use something like this. Our class kitten here, right? A simple, very, very basic class that simply remembers the attributes that you pass to it. That's good. That's kind of an okay way to represent attributes. And then if you need a little bit more functionality, for example, if you need to validate whether names and ages are correct, or you need to do some other complicated stuff, you can always kind of dress up your class kitten into a property kitten, which works with these property decorators and these setter decorators, right? So you can kind of grow your kitten into a more complicated organism, if you will. So I think that would be my recommendation, to use either of these two approaches. But it's a matter of taste, and I guess the most important thing is to be aware of the various ways in which you can represent attributes and objects in Python, and just choose the one that fits your personal taste and your situation best. Okay, thank you for your attention.